Hello, everyone.
Hi. Glad to be here. I'm Yann. I've been a software developer for over 10 years, an AI engineer for over 2, and I founded pAIrprog to focus on the development of methods and tools using AI for software development.
I'm Fabrice. I'm the co-founder of Theodo. I'm the co-author of the Lean Tech Manifesto. I've been coding professionally for 20 years, and my flex, since we're talking about AI, is I actually wrote, my only scientific article I ever wrote was about using GPUs for AI back in 2006. So we're here to ask the big question. Why do people still maintain 2 native apps? It's twice the cost to build new features, and it's twice the cost to maintain. And so I understand how people could justify that 5, 8 years ago when multi-platform was still edgy. But React Native is now an established technology. It's adopted by many of the best tech companies in the world. So the question is, why don't people migrate? And Yann says, of course, because migrations are very hard and very risky. Let me walk you through the 4 big challenges of any migrations. So the first one, legacy necromancy. As soon as the app is slightly old and complex, it becomes incredibly hard to actually extract the business rules from the people in the organization. Then you've got the reliability rupture. A migration is about replacing something that works with something that will not work as well, at least at first. You've got the feature famine, because you're asking business to stop any development of new features for months or years on the risky promise that it will be worth it one day. And finally, and not the least, migration mutiny, because you have to collaborate with the existing tech teams who are not looking forward to all the experience and the value of their skills becoming potentially worthless when you migrate to the new technology. So this is why we are stuck with legacy. It's not because we like it, but because it's so difficult to move out of it. And Gen AI is, of course, this very interesting technology that could change the game. Because on legacy necromancy, for example, you could extract the business rule. It can help extract the business rules and then translate them into compelling documentations. On reliability rupture, it provides a safety net by generating more test coverage beforehand. On the feature famine, the promise is, of course, to accelerate the migration by automating a lot of the code rewriting. And on the migration mutiny, well, AI does not solve people problems yet. But at least you can promise that using AI, it will help you master new technologies faster. So enough with the theory. We're here to share you a real-life example. So it's a health app that has been developed over 4 years by, on average, 3 developers. It's quite complex. It's got 140 screens. And after 4 years of working on it, so 2 native apps, iOS, Android, and TypeScript backend, a big new feature was planned. And so it was time to ask the question again, why do we have to build it twice? The issue is that the estimate to migrate these apps to React Native was about 9 months. And that was quite an issue. It's not a time period that the business could afford to do nothing. So what we kind of got out of the discussion is if it was 4 months, then it would work out. It would not only be short enough that the business could wait, and it also meant that the migration would pay for itself by, over the following 10 months by reducing the cost of the new features. So the idea was, could we do it in 4 months using AI? So Yann had been around working on how to use AI for accelerating migration for a while. So we turned to him and said, look, it's the time. Can you migrate this in 4 months instead of 9 using AI?
And I said, of course. Because I firmly believed that we could do it. But as you know, when money is involved, believing is not all it takes. And we had to answer a few big questions beforehand. The first one being, can it even work? We picked the iOS code base as a starting point because it had the cleanest architecture. But we needed to check if LLMs could even translate Swift code to React Native. So what we did, we just propped up ChatGPT, wrote a very specific prompt, which is basically, please write code. Then copy-pasted one of the screen's code with some of its dependencies, ran the LLM, copied the output, created a basic Expo app to paste the code in, ran the Expo app, and checked out the results. So as you can see, yes, it works. And it took us about 20 minutes to find out if we could do it. But as you saw, there was lots to improve. Starting with the randomness of LLMs. Because unfortunately, we will still have to maintain the new code base. So we didn't want the produced code to be all over the place. And in order to do that, we had first to figure out which was the right LLM to choose. So we set up an evaluation tool, in this case, PromptFoo, which allowed us to view the progress on our results, follow the progress on our results. We built over the prompt to add a few rules to try and constrain the output. And we ran these tests over the top 3 LLMs and code reviewed each result manually. And after a dozen of tests, the answer was a resounding fact that Anthropic Opus 3, now Sonnet 3.5, was the best model at the time, because it was the only one to follow every rule we gave it, and not trying, for some reason, to wrap our entire screen within a touchable component. So now that we were sure we could accelerate the migration and improve upon the results over time, the question was, could we actually achieve this project in 4 months? And to know that, we needed to answer 2 sub-questions. Which type of code can leverage LLM transpilation, and how much of it is there? And through a very scientific and rigorous formula, we would be able to estimate the gain. So we need to cut the code piece by piece to translate each piece into React Native. But you may wonder, what's a good piece of code? Well, thanks to a couple of very smart people, we already had an answer to that question. If we take a very simple framework like the MVC framework, it gives us a set of architecture primitives to help us structure our code base. So we've got the model, view, and controller. And fortunately, because our legacy code base followed the Viper pattern in iOS, it allowed us to quickly map it to a React Native equivalent and figure out which pieces from iOS would translate into which pieces in React Native. Now that we had defined our architecture primitives, we took 2 days to sample as many as we could in order to estimate the automation on each. And our goal was not to evaluate how many we could fully automate, but what percentage of their code could be written by AI. And by analyzing the results, our predictions showed up that up to about 3/4 of the migration could be accelerated by AI at varying degrees, which gave us about a 70% confidence rate in being able to migrate within the time frame. That's until our tech lead called in on our bluff. Because while the generated code was able to run with a few small rework, the code quality wasn't up to Theodo standards at all. Because LLMs are like postgrad students who have gone through an entire library but have never worked in a professional environment where getting a sense of the bigger picture is a requirement. But you know who has the bigger picture in mind? Where it's our tech lead. So by simply sitting with him and turning his feedback into rules we would inject into the prompt, we're able to considerably improve the output's quality. But all these actions didn't even matter if we weren't able to repeat the process efficiently. So allow me a quick digression. I don't know if you've seen the stories about the self-driving taxis in San Francisco, but did you know you can render them useless by simply putting an orange cone on their hood? Well, if you've ever gone through a migration, you know that the road will probably look like this. So instead of trying to build the mythical super AI agent to replace engineers during the migrations, I wanted to take inspiration from what we currently have in our cars to help us deal with the changing environments. Because when you think about it, without having to take out the wheel, modern cars already have plenty of automation systems to facilitate driving. And my goal was to do the same, retain developer agency while providing assist for the most common scenarios. And because, obviously, the IDE is the developer's car, I built a VS Code extension dedicated to technical migrations. And like modern cars, I focus on ease of use by simplifying the 3 main steps of coding with an LLM. For prompting, the extension picks the prompt based on the active file. And I also took the time to set up prompt components and syntax highlighting to encourage the development team to read and improve upon the prompts by themselves as much as possible. For context building, at first we would write hard-coded scripts to try and open the right files. But our latest iteration had us build an entire graph database out of the project's architecture to quickly open the right context. And to avoid busy work, of course, I automated response extraction and code formatting. So let's see how it works. Let's take this original iOS. Let's say we want to migrate this iOS screen. We would set up our editor into 3 panes. On the left, the blank file we want to generate code for. In the middle, the same file from legacy. And on the right, the logs from our extension. What you'll see is that first, we'll run the quick context command to open the rest of the required context needed to translate the code. Then we will launch the Transpilation tool, which will call the LLM, write the code to this file, and run the formatting on it. But that's almost only the starting point. Because the code you've seen is only the first iteration. And as you can see, it's still lacking some of the elements from the original screen. So for the second version, second iteration, we update the prompt with a dedicated rule on how to handle gradient background when coming from the Swift code base. And for the last version, after adding the missing pieces of context, we were able to fix the layout and with the light edits. So to conclude, the result, we managed to go through all of our 140 screens. And on the files where AI wrote the code, 70% was left as is. And with all the team's effort, we did manage to migrate in just 4 months.
So it's my opportunity to congratulate all the team that contributed at one point or another to that journey in migrating this app. It's a really cool story. Of course, the team is amazing, so maybe it's not the AI, maybe it's just them. But yeah, 2 key learnings I want to add to this talk. You've seen like real life experience. I'm bringing my 20 years of experience to see a bit of big picture. I think one of the big learnings of that project was the value of explicit architectural standards, because if it's not really clear what kind of architecture you expect, the LLM can and will produce a different architecture every time. And so that's particularly visible in the React world, which is non-opinionated, so you've got a lot of opinions. And therefore, we had to write down all these implicit assumptions that we had as a team and as a company. And it's been very interesting, of course. It also helps you finally document all the standards that are more like oral traditions. But it also shows you that these kind of projects will be much easier if you're targeting a very opinionated framework, such as, Django or Symfony. And the big learning number 2, Yann already hinted at it, but it was a question when we think about automation, a lot of us dream about these fully automated lines where it's only more robots and no more human beings. And it's interesting because you've got the same parallel in the car industry. When Elon Musk was very optimistic about Tesla production. At some point, he kind of promised he would like put robots everywhere, and then actually realized it didn't work because when you build a car, there are steps that are very different. Some steps are incredibly stable, such as painting, and painting has been fully automated with robots for a long time. But there are steps, such as assembling, where there's so much variability in input and in expected output that actually you can't. The robots are way less productive than human beings, and so therefore it's a lot about, if you want to improve automation, it's about really empowering the people, the operators on the line. And actually, what is very interesting is, I think for the last 30 or 40 years, the rate of automation on an assembly line has not increased. And Elon Musk was one of the guys who actually came back on his promise and said, you know what, human beings are actually quite cool. And the good news for us, probably as human beings, is that a migration is very similar. There's like such a variability in inputs. There's always like some kind of edge cases, and there's also so much variability in the expected output that any strategy trying to leverage migration will be about using it to empower us as devs to really like accelerate our work, but it will require us to do the variability and creative part. That's it. Thank you very much for listening to us. You can follow us on social media, on Blue Sky, on LinkedIn, and we're here to answer your questions. So thank you very much.
Thank you. Thank you very much. Thank you guys for your talk. Very interesting. I mean, I've known about this story for a little while, and so it's always cool to see it finally reach fruition rather than being in the weeds of it. So very cool. Congratulations to you. This is, I'd say, a very big achievement to be able to do something like this. Just a quick questions, and we're going to do this in about 4 or 5 minutes and try to get it out. So short answers are deeply appreciated. Does the 4 months of migration include the time to build the AI migration tools?
Yes.
Cool. How did you deal with iOS and Android specific parts of the app?
Oh, for iOS, and then you mean like bridges, native SDKs?
Yeah, let's say you've got native functionality.
We migrated them by hand. Like whenever React Native bridges were available, we used them, or we built them by hand.
Okay.
This is where AI doesn't shine, actually.
Okay. Good to know. What do you think are some of the weak spots of the migration?
On this one, in the next, if we were to redo it, we would put much stronger focus on testing and setting up the safety net.
Cool. What's the worst bug that the LLM ended up producing?
Whoa. It's been really good at migrating existing bugs.
Yeah.
What was the worst bug, though?
Whoa.
If you don't remember, that's fine.
No, I don't remember.
Go look at the code afterwards.
Yeah.
The person who's interested in that, come and fetch them.
No, but actually, it's one of the tough things with migrations is you end up detecting bugs that had been undetected this whole time, and it's quite frustrating.
Yeah, that makes a lot of sense. I think some of these stuff surface up when you're really doing a full-scale migration. How do you compare your extension that you had obviously built to Cursor?
Oh, the extension is built for can you say the word? Industrialization. Sorry. Because the thing with it's heavily focused on being able to repeat the exact same process over multiple of the same files. Like, for example, your screen, your component, your query, your mutation, like those types of files, the architecture primitives. The goal is to be able to do as little as possible when you generate each file corresponding to these types. And this is something that you could do with Cursor, but would require more work, especially in context building, like fetching the right files, opening them, adding them to the prompt.
Out of curiosity, how many architecture rules did you end up with for your prompts?
Rules? Whoa. For React, way too many.
So like the rules in your prompts that you set up, how large did that set of constraints?
It's usually one sentence for a rule.
Mm-hmm.
Like don't use default export, name your export according to the file name, for example. It's one rule. Then you could make it a bit more complex, add some examples, add some OKKO, so like for the do nots, show what not to do, then what to do. Examples work really well, but what's the best for to upgrade the quality of the output is actually like writing gold standard files, like being able to point to a specific file within your code that will be the gold standard to try and replicate.
And I guess the final one, just for a little bit of fun, did you use AI to build the AI tool?
Yes,
cool.
Of course.
Awesome. Thank you all so much for coming along and sharing the story.
Thank you, Mo. Cheers.